the frequency domain priors. This paper has been something which is more phenomenal in terms of what research can be today. We are seeing deep image priors in the information and a lot of other aspects. But frequency domain prior, I think this is one of the first paper which I saw. The authors of this paper are from University of Tokyo, Department of Electrical Engineering and Information System, Hong Kong, Tokyo, Japan. This paper probably is one of the most exciting one because I have never seen people working on these aspects. Abstract of this paper. This paper basically says the pixel training on a neural network using spatial domain information. However, there are more needs in order to get the right approaches, the right point. That means they were supposed to frequency image prior. There are discrepancies in color, boundaries, artifacts, distorted patterns, and blurry texture. To just extract from those spatial domain information, discrete Fourier transform, and other techniques have been employed. This paper proposes a deconvolution module that enables the network to learn a global context while selective reconstruction of the high frequency component, which is black images turning into a successful way of getting the hidden pixel which will disappear all of the sudden. This paper was implemented on a publicly available dataset of Salabé and Paris Street View. This is both feasible both qualitatively and quantitatively because the computation was on point. Keywords are these. Basically, this is one of an approach given for generative adversarial networks in order to give the right computation. Recent research works in the image inpainting have the leverage of generative adversarial networks and also neural style transfer. There are a lot of ways in which this technology has worked. There are stages of implementation which we discuss in the future. In the first stage, the missing regions are coarsely fine. They are basically coarse-grained array of numbers which have been number crunched and get the reconstruction losses. In the second stage, initial reconstruction regions are defined by an adversarial loss. There are a lot of features like adversarial attacks which have come into the picture. Adversarial loss is one of the features which they have taken into the consideration. Adversarial attacks happens even when your data is not having right amount of information, or else if it has more amount of biases towards the false positives. Thus, a real complex scenario where they are basically spatial domain and the frequency domain information into one of the key factors. In computer vision task of filling many pixels, the inpainting is something which is common because there are a lot of techniques which are involved. In this main challenge, the task is to synthesize a mixing pixel in a way that it looks visually realistic and coherent to a human eye. It's basically based on a perception. Probably there are pixels which have been missing. There are ways in which frequency domain priors have not worked, but yet this is one of an approach which give that realistic view for a human eye. The traditional image prompts are categorized as diffusion-based image inpainting algorithm, focusing on propagation of image appearance only. Although these methods fill in small holes and produces the smoothened result. Probably there are Gaussian filters which does the same job. Result of the hole gets bigger. That means the diffusion-based imaging inpainting algorithms, which focuses on proposed pixels of those pixels, can fill in bigger holes, but they are more effectively either in inpainting or in the missing regions that are complex structures and generative unique patterns or novel objects that are not available in an image in the form of a patch. The patch can be a pixel of white or blue, but yet this image data set mostly says the black patches. Therefore, adding the frequency domain, spatial domain information certainly improves the inpainting performance compared to the convolution of spatial domain image inpainting algorithms. Spatial image inpainting algorithms take a lot of time. That means if it's in a form of time or in the frequency, it's not a matter. It's all about the computation of the matrix. And also in terms of visual quality and evaluation matrices, probably there is an involvement of state of the art neural style transfer algorithm, the best knowledge which the neural network can gain. In this work, we explore the effects of what frequency domain information in the image in painting can be, and also what neural stem cancer could have done for the global context of the image regeneration. This is where they are effectively using the TFT, the ground truth of the images, and they are basically getting that information. Probably there is a lot of view, there is a lot of pixels which are missing, there is a lot of biases which have happened in the dataset, but yet at the end of the day, it's an information which you are getting it. It's visually appealing. The results are so good. Probably other 5 years or 10 years, probably with the use of millions of data sets, they can give more accurate results. There are related works which have gone prior, so do check this slide out. However, these methods are existing image patches have low level image features. Therefore, they are not affecting in fully complex structures but performing semantically aware patch selection. Semantics have been that algorithm which have been working on this model. There can be a lot of equations which are learned by the model. There are a lot of features which can be extracted, but yet there is a lot of new aspects which an image has to learn. Most recent adversarial learning based inpainting algorithms have shown promising results, but yet this frequency domain prior is going to give less amount of compute resources. Even with a less amount of compute resources, it's going to work the same. The proposed model predicts the segmentation of the labels and corresponding image first and then fill the segmentation mask so that it can be used as a guidance to complete the image with this semantic information. The overview of a frequency domain based image in painting framework. The deconvolution network is trained in the frequency domain. Losses have been learned for mapping. DFT for the masked image and the original image. Original image can be something which has a ground truth, but masking such a patched layer can also give a good amount of information. These are some of the masks which they give in terms of the filters. Filters are basically that one of an entity which are programmed on a set of hardware and also by using some software in order to give you this mask in order to extract that information. There are ways in which stop band, pass band, low pass, high pass filter have worked, but yet these are the old school techniques in order to extract the information. This is a pseudocode of an algorithm which they are working upon. This can basically change the way in which the entire state of the art technology is working today. These are one of the DFT applications which they are taking. These frequency domain priors are basic information which they are taking. Parameters might change, but yet the complexity of getting the right information acts as frequency domain, according to this paper. There are a lot of patches which have been given out, but yet it gives some accurate results. This is one of the form factor, and where you have to keep in mind there has been millions of trials which have been going on in GANs. Probably it might take a complete model to get it trained. Probably it might take 4 days to 5 days, but there are a number of iterations which a model goes. There are a number of iterations which the model has to learn. There are a lot of parameters. Thus, don't get fantasized by the way this paper has been given. There are hundreds of trials, probably 20 plus of trials which have happened. This paper basically gives the rise of the quantitative evaluation, and this is one of the techniques which they use in a lot of communication system. Frequency domain, if it comes up, it's all about the communication, the technique which they use in retrieving the information. Thus, quantitative evaluation is one of those contextual encoders, decoders, lot of MAC units which have been designed. Ablation study is basically one of the key techniques in AI. AI has actually grown up in a form factor where there is no chance that you get way that there is a chance that frequency domain had no filters applied. There are filters applied, but they have been computationally hidden because the complexity of getting the algorithm of inpainting is much more bigger than the filters. There are input stages which have been applied, then output has been made available. There are a lot of patches which have been worked. There are a lot of textual information. There are a lot of information on the texture which had to be learned from the system. Thus, probably it has taken more than 20 plus iterations of training, and cycles of epochs probably can be up to 10. Quantitative results of Celeb A and Paris Street View on DDD, structured dataset. All these datasets have got their results in terms of, which is mind blowing. There are a lot of ways in which there are other competitors and also other techniques have worked, but yet this paper gives a phenomenal result. Conclusion: there are very minute details, sharper details which have been missing, but yet there can be work in other form. Discrete cosine transform can solve this kind of image restoration task. Image denoising can also be one of the applications. There are autoencoders which have been involved, but yet probably if there is an use of GANs as a set of algorithm, it can give more accurate. Thank you.